In this lab, you've been tasked to set up VLAN 30 for the HR department on switch 1, and you've been tasked to set up VLAN 30 for HR and VLAN 40 for the IT department on switch 2. VLANs, or Virtual Local Area Networks, logically divide a network into separate broadcast domains. This allows us to group devices independently of where they are physically located. I can be on a switch on the first floor and you could be on the second floor, but if our switches are connected and are in the same VLAN, we'd be in the same broadcast domain. In this case, our company created VLANs for each department, HR and IT. Let's start with switch 1, which only has the HR department. To configure VLANs on a Cisco switch, create the VLAN with the command VLAN 30. This creates VLAN 30 as an isolated broadcast domain. Then we'll assign a name with the command name HR-department. The name identifies the VLAN purpose or department. Now we have to attach the VLAN to switch ports so that the data that passes through those switch ports are tagged with the VLAN ID. Let's jump into the interface that the PCs are attached to. Interface Fast Ethernet 0/1 for PC 1. Then let's use the command switchport mode access. The switchport mode access command configures the interface as an access port. What is access mode? Access mode is used to connect single end user devices to a port like a PC or a laptop. In access mode, a port can only be assigned one VLAN and prevents the port from becoming a trunk port. The only time an access port can have two VLANs is if there's a voice VLAN attached. This usually happens when office computers are connected to IP phones. The computer uses an Ethernet cable to connect to the voice over IP or VoIP phone, and then the VoIP phone is connected to the jack port on the wall, which then connects to a patch panel and eventually the switch port. This makes it so that both the voice data and the regular computer data go to the same switch port. Here's an example of how a voice VLAN would be placed on a switch port if we needed it. We'd have the commands switchport voice VLAN and then the VLAN ID. Then we'd use the MSL QoS trust COS command. The MLS stands for multi-layer switching. The QoS stands for quality of service. The trust COS part means the switch should trust the class of service for packets that come into this port. The command basically helps to make sure packets in this voice VLAN have a higher priority. We want voice packets to have a higher priority so that when someone is on an IP phone, their voice will be clear because their packets are getting the white glove quality of service treatment. Since we don't require voice VLAN, let's attach the VLAN we did create to the switch port with the command switchport access VLAN 30, which assigns the access port to VLAN 30. Now at this point, PC 1 is on VLAN 30 and PC 2 is on the default VLAN 1. So if we try to ping PC 2 from PC 1, notice that it won't work. In order for VLANs to talk to one another, we need a router, just like if the PCs were in two different IP networks. Now, we'll attach VLAN 30 to Fast Ethernet 0/13 for the switch port PC 2 is connected to. That way, PC 1 and PC 2 will be able to communicate with one another. So we use the commands interface Fast Ethernet 0/13 switch port mode access, switch port access VLAN 30. To verify the VLANs, let's use the show VLAN brief command to display all the VLAN IDs, names, and port assignments. Notice how we can see VLAN 30 with the same HR-department name we gave it. Also notice how the ports we assigned VLAN 30 are listed on the VLAN 30 line. The default is VLAN 1, which is why all the other ports are part of VLAN 1. We can also use the show VLAN ID 30 command to verify the details of VLAN 30. We're mainly concerned about the status and the ports associated. With this configuration, when devices are connected to ports 1 and 13, they can talk to other devices in VLAN 30. They send messages called layer 2 frame data. This keeps their messages separate from other VLANs so only devices in VLAN 30 can understand them. Essentially, VLANs let you put devices into groups based on what they do or who uses them, instead of where they are. This makes it easier to manage the network and change things around. How does it help improve network management? VLANs, or the virtual local area networks, logically divide a network into separate broadcast domains. VLANs help make the network less crowded by only sending broadcast messages to devices in the same group. VLANs can keep important information safe by separating it from the rest of the network. VLANs also make it easier to make changes to the network, as devices can be moved between VLANs without physically changing their location in real life. Also, VLANs help the network work better by putting devices that talk to each other a lot in the same group. Remember to save your configuration and your packet tracer file. Also, update your work documentation notes. Now, try that ping from PC1 to PC2 again. Notice how they now work. That's because their traffic is tagged with the same VLAN ID this time around. Now let's move on to switch 2. On this switch, we want to have two separate broadcast domain VLANs, one for HR and the other for IT. PC3 and PC4 are in the HR department, and PCs 5 and 6 are part of IT. So let's first create two VLANs, VLAN 30 for HR, VLAN 40 for IT. Perfect. Now let's assign these VLANs to the right switch ports. We can select more than one switch port using the interface range command, interface range fast Ethernet 0/1 through 2. Then let's add the switch port commands, switch port mode access, switch port access VLAN 30. Then let's attach VLAN 40 for the switch ports PC5 and PC6 are connected to. Then save the configuration and save the packet tracer file. Let's verify our VLAN information on switch 2. To verify the VLANs, let's use the show VLAN brief command, which displays all the VLAN IDs, names, and port assignments. Then let's use the show VLAN ID 30 command to verify the details of VLAN 30. And show VLAN ID 40 command to verify the details of VLAN 40. Now try pinging from PC3 to PC4. Notice how they work because they're in the same VLAN and the same IP network. Then try pinging from PC3 to PC5. See how that didn't work? That's because they're on separate VLANs and IP networks, and since there's no router, the traffic can't be routed between the VLANs and IP networks. Usually VLANs and IPs are separated in the same way to match one another. For example, each device of VLAN 30 will share the same IP network, while each device of VLAN 40 will share its own separate IP network. Sometimes, VLANs are used by DHCP to assign IP addresses in a specific network, which helps organize the separation. Make sure to update your notes. Now, let's connect switch 1 and switch 2. To connect the switches and have the VLAN traffic move between them, we need to connect the switches using a trunk port. A trunk port can be static or dynamic. What's the difference? Think of a trunk port as a highway that lets data tagged with IDs travel on it between devices. A static trunk port is like a highway where the path is always open between the two ends, with the data having specific IDs based on which switch port they came from. A dynamic trunk is like a highway also, but in this case, one end negotiates with the other end to create a path to allow the data with the different ID tags to travel between them. So let's create a static trunk port. First, we'll connect the two switches together with a crossover cable. And make sure the ports are enabled with the no shut command if the ports are not already up and up. Let's start with switch 1's half of that static trunk. We know which ports we connected the switches to, since we literally just did it, but if we wanted to, we could use the show CDP neighbors command in switch 1. By doing so, we can see switch 1 is using port G01 to connect to switch 2's port G01. The show CDP neighbors command means show me the devices connected to this device that also have the Cisco Discovery Protocol enabled. That's what allows us to see the other Cisco devices connected to the one we're on. If CDP was disabled on the other devices, we wouldn't see them. But for now, it's enabled, so we can see that switch 1's port G01 is connected to switch 2's port G01. So let's get into the configuration mode of G01 so we can make it a static trunk. To make it a static trunk, we need to run the switchport mode trunk command to turn it into a trunk for VLANs to go across. Then we have to do the switchport no negotiate command, which tells the port not to negotiate the trunk, meaning it's static and not dynamic. If it were dynamic, it would try to make switch 2's G01 port, the port switch 1 is connected to, into a trunk port. And again, if it were dynamic, the two ways to stop it from becoming a trunk port would be if switch B's G01 port had switch port no negotiate or switch port mode access configurations on it, because it would then ignore switch 1's request to become a trunk port. Once we set up the port to be a trunk, and for the port to be static, we now need to apply the native VLAN to the trunk port. The native VLAN will make it so that any traffic that is not tagged with a VLAN will be given this default VLAN tag. In this case, management told us the native VLAN is VLAN 100. So let's use the command switchport trunk native VLAN 100. Perfect. Now save the configuration and pause here to do the same on switch 2's G01 port. Ping PC3 and PC4 from PC1 to see how they can now reach one another. Once that is complete, management has told us that they configured SSH for switch 1 and 2, but the switches need a management VLAN and IP so we can SSH to them from the IT VLAN. In order to do that, we first need to create the management VLANs on the switches. Let's start with switch 1. So for switch 1, as the IT VLAN is VLAN 40, we need to create and name VLAN 40 to be our management VLAN. Because there's no router, we need our IT VLAN and our management VLAN to share the same IP network and broadcast domain. We're going to use this VLAN as a switch virtual interface, or SVI. A switched virtual interface allows layer 3 IPs to be assigned to a layer 2 data link layer switch. This switch IP helps management SSH into a switch to remotely access and configure it. So let's set up the switched virtual interface by going into configure mode of the SVI VLAN, which is VLAN 40, with interface VLAN 40. Then let's apply an IP address in the same range as the IT VLAN 40 PCs, so only those IT PCs can access it. Luckily, management has already given us which IP to use for switch 1's SVI. IP address 192.168.40.99. Subnet mask of 255.255.255.0. Now let's save the configuration and update your notes. Then, pause here, jump into switch 2. We already have the VLAN created, so we just need to configure it to apply the IP address and subnet mask management provided us for switch 2's SVI. Then save the configuration and save the packet tracer. Now try to use PC1 to SSH into one of the two switches. It shouldn't work because it's not in the same IP network as the SVIs. Then try to SSH to switch 1 or switch 2 using PC5 or PC6 to make sure it works. Use the username and password management provided to log in. Perfect. Now, update your notes and then create your narrative. After that, share the Google Drive folder you have for this lab with the anyone with a link can organize, add, and edit access. Then submit the lab for review. If you don't know how to submit the lab, refer to the instructions in the lab's intro video section of this program. After that, you can move on to the next lab.